One of a very important subject in mathematics is the calculus. And not many people understand the calculus, especially the multivariable calculus and vector valued function and so on. So what we are going to do is we start a new course on calculus not multivariable calculus, since I'm going to start from chapter 11 of Thomas Calculus 15th edition. So there is not much difference between 14th edition and the 15th edition. So I already made a course on this subject, but chapter 11 and 12 was not included in that course, which is calculus 3. So what we are going to do, we are starting from chapter 11 and reach at chapter 16, which is very important in mathematics. What is the difference between previous course and this course is that we are going to see animation in almost concept will be covered through animation, so your understanding will be increased. So let me just start a course. So we start from chapter 11 and we will finish this course in chapter 16. It will take some time so to finish the course, but we will start it anyway. So first we have section 11.1, and 11.1 discusses the parametrization of plane curve. Plane curve mean that all the curves that you can draw on the xy in the xy plane, like circle, ellipse, parabola, so on and so forth. All these curves are called plane curves. What is parametrization means? Parametrization means that you introduce a parameter so that you can draw a curve. You can draw a plane curve. You will see in future that we will talk about the space curve as well. So here we are starting from the plane curve. So what is the definition? The definition is if you have, for example, write x is equal to f of t and y is equal to g of t over an interval I of t values, then the set of points defined by these equation is a parametric curve, and the equations are called parametric equations. So it means that you can actually, for example, if you have y is equal to f of x, simply y is equal to f of x, simply you can write this as x is equal to f of t and y is equal to g of t. Let me just show you first example. For example, we have this x is x which depends on t and y is t, and t is 0 to 6. In first case, you draw a table, you give a value to the t. Remember that this t is not on the x-axis, neither it is on the y-axis, but it is just a parameter. That's why these are called parametric equations. Put all the values from 0 to 6, you get x is equal to 0, y 0, t is equal to 1, x is equal to 1, y is equal to 1, so on. So you draw this curve. I will show you this curve in animation. You will see that now. Uh, Here you can see this is the curve which is drawn in the book. The motion starts from t is equal to 0. T is equal to 0 mean origin. Then you go along the curve and reach at t is equal to 6. All t values give you the point. Remember that when you give a value to the t, then you get the point. So every t corresponds to the value of a point in the xy plane. As you can see over here, there is an arrow. So arrow shows that the direction of motion is on this curve. It shows the direction of motion simply. If the arrow is on the opposite side, it means that the motion is on that direction. Let me just show you the same example in animation. I already created this animation. You will see over here. So as you can see that this object started its motion from origin. This is origin. On the right hand side you see positive, on the left hand side you see negative points. So this object started its motion from origin, then it moves along the curve. That's why we have an arrow in the curve. We run it. So you can see that the object started its motion from t is equal to 0, and this is t is equal to 6. Now next example. This is second example. You see the parametric equation of some curve. We will see what that curve is. X is equal to t square, y is equal to t plus 1, and t is minus infinity to infinity. In fact, t, in theory, t cannot take values from minus infinity to infinity. It just shows that you can take any value between minus infinity to infinity. We cannot take t is equal to minus infinity and t is equal to infinity. Otherwise, this x will be infinity, y will be infinity. When we draw a table, we have to decide for which t you want to draw a graph. So we decided t should be minus 3 to 3. X is, you get the value of x. For example, t minus 3 gives you x is equal to 9, and t is equal to minus 3 gives you minus 2. So you get the first point, which is 9 and minus 2. Let me just show you the image. When t is equal to minus 3, you can see that the first point we get 9 minus 2. For t is equal to minus 2, we get 4 minus 1, so on. And you can see the arrow which shows that the object started its motion from t is equal to minus 3 and it reaches at t is equal to 3. Let me just show you the animation. For example, the object started its motion from t is equal to minus 3, and as you can see that this is a parabola uh, opening towards the right, and the object started its motion from t is equal to minus 3, and it just follows the path. Okay. So we go to the next example. In next example, we want to see what these curves are. For example, these two parts shows that there are two curves. One has x is equal to cos t, y sin t. So what we do, we simply square each component and add that, and we can see that this is a circle. So the circle is written in part A. And similarly for part B, there is a involved in that, which can have any value. So in that case, we have a circle with the radius of a. In a part, we have a circle with radius 1. So we see the animation over here. First, for example, I should run it again. You can see that there is a circular motion. Object has started its motion from here, then it was moving on the curve like this. This is the circle with center 0 and radius 1. On the right hand side, we have part B, where I have given a value of a is equal to 2. This means that the circle has a center of 2 and origin is at 0, which origin is over here. We run the code. You can see the object is moving on this circle.